All right, today we're talking about composite figures, and a composite figure can be a plane figure made up of simple shapes, or it can be a three-dimensional figure made up of a few simple three-dimensional figures. But notice here we want to find the perimeter of this composite figure, and well, really the only way we can go wrong here is just making silly mistakes. The perimeter is the distance around an object. Do not worry about this dashed line right there. That's going through the center. All we have to do is add up the distance around. 5 plus 3 is 8, plus 4 is 12, plus 7 is 19, plus 4 is 23 feet. All right. All right, we have a few things that should make sense. All right. First postulate up there says if two polygons, if any two polygons are congruent, then of course their areas are going to be congruent. And that should make sense to us. The second one here says the area of a region, all right, so we're thinking about that region's kind of referring to those composite figures, is equal to the sum of the areas of the non-overlapping parts. So the area of this entire composite figure, this region, would be the area of that triangle plus the area of this rectangle plus the area of that triangle up there. We can just add up the pieces. Here it says find the area of this composite figure. So there's a few things we can do. The first thing I noticed, which should be pretty easy for us, is finding the area of that rectangle right there. The area of that rectangle, of course, length times width. That gives us 51 square inches. I need to find the area of this triangle, and notice I'm given the height. The base is simply going to be 8.5 inches because we know that the opposite sides of a rectangle are congruent. And to find the area of this triangle, I'm going to do 1/2 my base, which is 8.5, times the height, which is 4. You do need to think of that triangle as almost turned, so this 8.5 is the base, and the height is that 4 inches going straight from the base to the apex of that triangle. And if I type this in here, I get 17. And so 17 is the area of this triangle. Notice these two triangles are congruent. So 17 is going to be the area of that triangle. And so the area of our composite figure, add up all these areas. That gives us 85 square inches is the area of this composite figure. Here we want to find the area of the shaded region. So we can find the area of this entire rectangle and then subtract away the area of that triangle right there. That should make some sense. That would give us what's left over is going to be that shaded region. So the area of this entire rectangle, well, the area of that entire rectangle, length times width, base times height, this entire rectangle is 390 square millimeters. The area of this triangle right here, we're given the base, we also have the height, and of course that's going to be 1/2 the base times the height. And that comes out to be 132 square millimeters. We want to find the shaded region. Well, this is the area of the entire rectangle. We need to subtract that, and it'll give us what's left over, what's shaded. And when we do that, 390 minus 132, the shaded region. Well, this is 258 square millimeters. Okay. Finally here, we've got plans for this pool. It's going to form part of our new downtown plaza. The edge of the pool needs to be tiled. What is the perimeter of the pool? That will need tiling. Well, if we want to find the perimeter of the pool, okay, we don't want to go all the way on the outside. We just want to go the perimeter of the pool. Don't worry about the dash lines. We want to find what they're asking for. Well, that's going to be 60. This right here, it's a rectangle, so that's going to be 25. That's going to be 40. So it's going to be 60 plus 25 plus 40 plus 50 and 60. Over here, again, that's 25, that's 40, because that's a rectangle. So we're going to add 25, we're going to add 40, and we're going to add 50. We're adding up these distances all the way around, and we got right back to where we started with that 60. We add them up. And we get 350 yards. That is the perimeter of the pool.